All righty, hello folks. How are you guys? One final section together as we go through this first chapter. So the last part we're going to look at is logarithmic functions. Now, we need to remember some things about logarithmic functions here. The logarithms are the inverse of exponents. So we already talked about exponential functions last time. So we said for exponential functions, that was some function that looked like this, where they had some sort of base and the value of x. And then we said that there were 5 primary points we wanted to use: -2 and 1 over b squared. And then we had -1 over 1 over b. We had 0 and 1. We had 1 and b. And then we had 2 and b squared. Then when we graphed it, well, first of all, we said we were going to take these points. Let's see, let's change the color. And we were going to use these points to help us figure out what our g of x was. And that's when we went through and we did all our transformations with a, b, c, and d, or a, b, h, and k. Well, then from there, we went ahead and we looked at the graph of it. And we said that for each of these functions, if the base was a positive number, it was exponential growth. If it was between 0 and 1, it was exponential decay. But ultimately, they had some form of looking like this. They would get really close to that x-axis, but they wouldn't touch. And then the reason why they didn't touch is we said, well, they have something called an asymptote. So they get really close to that horizontal asymptote, but they never touch it. Now, horizontal asymptote, this was the line y equals 0. And then we said, well, after we do our transformation, that asymptote was y equals whatever the d value was. Or if you're using h and k, y equals k. Well, this was exponential. So, and the reason why I'm spending a little bit of time looking at that is, again, we mentioned that exponential graphs, exponential functions, are the inverse of logarithm functions. So we're going to actually end up doing the exact same thing we did before. We're just going to make a couple small changes. So just like the base of the exponent, we also have the base of a log. All right, there's our base right there. So if they're inverses of each other, that means if they're inverses of each other, they're reflected over the line y equals x. So let me see if I can't draw a line y equals x here. They're reflected over the line y equals x. And if they're reflected over the line y equals x, that means for the inverses, when we find the inverse equation, we took all the x's and y's and we flipped them. Well, we can do the same thing here with these points. So where this was -2 and then 1 over b squared, well, for our log, those are going to be the opposite points. So the y value for the exponent became the x value for the log. And the x value of the exponent became the y value of the log. So it's the same points, it's just we are flipping the x's and y's. So let me write up our last little point here, b squared. So these would have been the f of x points for the log. And then we're going to use our transformations, the a, b, c, and d, to figure out g of x, just like we did with transformations, just like we did with the exponents. Now, something to remember also about our log is if they're inverses, the horizontal asymptote of an exponent is going to flip, and instead it's going to become the vertical asymptote for a log. So that would be the equation x equals 0. But just like y equals d was the asymptote when it was transformed, the d doesn't go with y. Instead, it's the c value that goes with x. That's the thing that shifts the graph left and right. So the vertical asymptote is going to actually be x equals c once we finish off our transformations. And then for the graph itself, this is the point 0, 1 on the exponent. So this is going to have a point at 1, 0. So it's going to come up to 1, 0, and it's going to go out. And it becomes then the reflection over the line y equals x. So that's what we're playing with today. It's going to be pretty much all the same exact stuff. And also, just like before, we're going to have to make an explanation. So just as a quick reminder, the explanation we have to make is we have to say what the domain is, what the range is, what the x-intercept is if it has one, what the y-intercept is if it has one, and what the asymptote is, and it will indeed have one of those. Okay, so that's going to be what we're playing with today. So let's try this. To begin with, just like before, we're going to factor out all of our information here. So we're going to take our g of x. Let's factor out that b value. So that negative in front really is -1 times log. I have a base of 3. So that means I have, that should be in a bracket there. So I'm going to factor the 2 out of the parentheses, and that makes that x minus 2. And then we have plus 1. So that means our a value then is going to be -1. Our b value is going to be 2. Our c value is also going to be 2. We got those 2's. And our d value is going to be a +1. And to figure out what parent function we're looking at here, we're going to take the base. And that means the parent function we're actually playing with here today is f of x. log base 3 of x. So let's start off. Let's get our points for f of x. So we have 1 over b squared negative 2. So we're going to flip them. So take that base and we're going to square it. So 3 squared is 9, but that goes in the denominator. So I have 1/9 over negative 1/9 and negative 2. And then we have 1 over b, so 1/3. Negative 1. We're going to have 1 and 0. We'll have 3 and 1. And then last and certainly not least, we'll have 9. And we'll have 2. So that's going to be our information. And remember, just like we do with transformations, just like we do with exponentials, we're going to still do the same thing with a, b, c, and d. So our x value is going to be divided by our b value. This doesn't change from what we've been doing earlier this week. And we're going to add our c value to it. We're still going to take the a value and we're going to multiply it by the y value. And then we're going to add d to it. Oopsies. Quite a d. There it is. And we get those points, and those will be the points g of x. Let's make our table here. All right, so just like we did transformations, just like we did the exponentials, we're going to plug our numbers in here, and we're going to figure it out. So let's see, our b value, just so I'm aware, the b value here is 2. So I'm going to be taking, what I'm really doing here is I'm going to be taking the x's and dividing them by 2. And the c value is 2 as well. So x divided by 2, and then I'm going to add 2 to it. The a value is -1. And the d value is +1. So we're going to have 1/9 we're going to divide it by 2, and we're going to add the other 2 to it. We're going to take our a value, which is -1. We're going to multiply it by the y value, and our y on this one is -2. And then we're going to add our d value to it, which is a +1. So 1/9 divided by 2, that's 1/18. That's like 1/9 times 1/2. So 1/18. And then we're going to add 2. So 1/18 plus 2, that would be 2 and 1/18. I don't think I'm going to be able to grasp something that small. And then the y value, -1 times -2 is 2, plus 1 is 3. We're not graphed on accurate, or we're not going to be graded on accuracy. Just we're going to try to make our sketches as close to what they are as possible. So why don't you go ahead and pause the video and see if you can't come up with those other 4 points. All right, well, when I did it, here's what I got. I got 2 and a 6. And then I got a y value of dose. I got, I can't read my writing, 2.5. And I got 1. Then I got 3.5. and I got 0. And then the last one I got was 6.5. And -1. So I'm going to go ahead and graph that here. So let's see here. I don't really have anything on the negative side. There we go. 1, 2, 3, 4, 5, 6, 7. 1, 2, and 3. All right, let's try that. So first up, we have an asymptote. Remember that the asymptote is always this c value. So if our c is 2, that means I have a vertical asymptote at x equals 2. All right, 2 1/18 and 3. So let's see, that's going to be really, really, really close to the 2 1/6 and 2. That's also pretty darn close. 2.5 and 1. That's going to be off a little bit. 3.5 and 0. That'd be right about here. And 6.5 and -1 would be right about here. So we can make our sketch then. A little whoopsie in there. I'll tell you what. There we go. All right. So the domain. No, let's start with the asymptote. Actually, I think the asymptote would be x equals the c value. So x equals 2. And then we have our y-intercept. If you notice here, here's my asymptote. I can't cross the asymptote, so I can never reach the y-axis. So turns out I don't have a y-intercept. I'll just call it D and E. The domain, that's going to be any value that's greater than 2. So x is greater than 2. But if I wanted to, again, we could use the same parenthesis bracket notation. I could say 2 to infinity and beyond. All right, let's see here. Our range, all real numbers. And then our x-intercept. Well, the x-intercept is when our y value is 0. So that's gonna take a little bit of work here again. So let's try that here. Let's put y in for 0. I'm gonna have to do a little bit of math, not quite as much as before. So if I plug 0 in there, I'm going to subtract 1 from one side and then divide by -1. So that would be, well, -1 divided by -1 would be 1. So I get 1 equals log . I just realized I have the y-intercept down there, but I want you guys to get an idea that we can still do the same thing we did before. So we're going to change the form now. So we're going to leave log form and we're going to go to exponent form. So my base here will become the base of my exponent. And I'm going to change what it's with. So 3 to the first equals 2x minus 4. So 3 to the first is 3 plus 4 is 7. So my x-intercept should have been 7/2 or 3.5, which we had right here. But if it doesn't show up in the table, that's how we would have found it. Alrighty, friends. So what you're going to do is you guys are going to try this one right here. So I'm going to write it up here. I know you have it on your notes, but I'm going to write it up here. That way you can use this as a little bit of a guide to help you out a little bit. We have 1/2 log base 2 of 1/3 x minus 1 all that is going to be then subtracted by 2. All righty, friends, go ahead and pause the video and take a shot at it. Well, here we go. Begin with here. We're going to always factor out our b value. So g of x is 1/2 log base 2. And we're going to factor out the 1/3 out of it here, so 1/3. And that, when I divide 1 by 1/3, I get 3. I still have a minus 2. So a is 1/2. B is 1/3. Play with some fractions here in a little bit. Our C value, or H value, is 3. And the D value, or the K value, depending on whatever one you use, would be -2. We'll use this right here to help us figure out what our parent function is. So our parent function is going to be a log of base 2. So let's plug those in here. Here we go. We have our f of x. And so since our base is 2, the base squared is 4, so we're going to have 1/4. And -2. We'll have 1/2, 1 over the base, with -1. We'll have 1 and 0. We'll have the base 2 with 1. And we'll have the base squared, so 2 squared is 4, and it is 2. And again, we're going to use our transformations here. So we're going to take our x value, and we're going to divide it by our b value. So we're going to divide it by 1/3. And then we're going to add our c value, which is 3. And then we have our a value, which is 1/2, times our, oopsies, not what I wanted, times our y values. And we're going to add that to our d value, which is -2. And we'll use that to get our g of x values. And again, also, friends, if we look at this here, we can already tell right at the very beginning where our asymptote is going to be. It's going to be that c value. So let me make my table here. Telling you, a little car sound always helps out a little bit. There we go. All right. Well, again, friends, I've told you before, I don't like dividing by fractions. So anytime I divide by 1/3, that's the same thing as multiplying by 3. So I'm going to go ahead and change that. So 3 times x plus 3. That'll be easier for me to follow along with. And then I have 1/2 y. And plus a -2, that's the same thing as just -2. So these are the values I'm really going to be using here. And just like before, I'll do 1, and then I'll just list the points again. So 3 times my x value of 1/4 plus 3. Then I'm going to take my y value, so 1/2 times my y value. In this case, the y value is -2. And I'm going to then subtract 2 from it. So 3 times 1/4 is 3/4 plus 3. That gives me a x value of 3 1/4. And my y value then, half of -2 is half of -2. Well, that shouldn't have been a -2. Oopsies. So that didn't sound right to me. There we go. Half of, let's try that. Half of -2 is -1 minus 2 would be a -3. So a little bit better. Yep. So then we can go ahead and get our points here. So the other points I came up with 4.5. And -2.5. And I got 6 -2. I had 9 -1.5. And last and certainly not least, 15 -1. So we can graph it. Let's see, we have 1, we got 2, we got 3. And we'll throw a token 1 in here for these guys. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I'm sure your graph looks just a little bit more accurate than mine. All right, again, we had our asymptote, x equals 3, so let's throw that in there here. Looks like because of this, we're not going to end up with a y-intercept again. So 3 1/4 and -3. Be right about here. 4.5 and -2.5. That'd be about right about there. 6 -2. 3, 4, 5, 6. 9 -1/2. 7, 8, 9. That'd be right about there. And 15 -1. So we don't really get to see the drop too much, but we can see how this thing is really, really, really flattening out here. We really see that flattening out. And we can use that now to answer some of our questions here. So domain, range, x-intercept, y-intercept, and our asymptote. Well, the asymptote is pretty easy to see. Again, it's just a c value. So the asymptote is x equals 3. I can also see that I'm not going to cross my vertical asymptote, so I won't have a y-intercept again. If I did have a y-intercept and I had to find it, I would just plug 0 in for x and go find the y value. Domain, well, it looks like it's greater than my asymptote, so I would say then x is greater than 3. Or again, if I wanted to write it in my other notation, 3 per, there we go. And my range would be all real numbers. And then last and certainly least, or certainly not least, is the x-intercept. And again, this time my table didn't tell me, so I have to go literally figure that one out. So that's a little bit of a bummer, but no harm, no foul there. So I'm going to go ahead and start here. I'll put 0 in here. I'm going to put 1/2 here. Log base 2. And what do we got there? 1/3 x. We're going to add the 2 to the other side. All right, let's see here. And then from there, we're going to have to go ahead and get rid of that 1/2. So I'm going to multiply both sides by 2 to get rid of that 1/2. Right there. So we got 4. One-third x minus 1. So here's my base right here. So my base of my log is going to become the base of my exponent. So I have 2 to the 4th equals 1/3 x minus 1. So 2 to the 4th is 16. And then we have, to get rid of the minus 1, we're going to add 1, so that's 17. And you can already see here that there's a reason why we never got to it. It would have been way out there. And then to get rid of that 1/3, we got to multiply it by 3. So 17 times 3 would be 51. That means the x-intercept is going to be at 51. That is really, really, really far out there. So we won't see that on that graph. We're not going to go that far, but that's okay. So we have 51, 0. There we go. All right, friends. Well, there you go. We did exponential graphs last time. That's part of the transformation ESA. Obviously, transformations are part of the ESA, but these log graphs also are part of the transformations ESA. So practice up. I'll put some more extra practice online for you guys to kind of play with it a little bit. But you guys are finished your first unit of pre-calculus. Nice job. All right. Have a great afternoon.